Hi, today's video is going to be looking at the different aspects of a function which we have talked about, but we're going to be bringing that on to the calculator. So there are three important parts of the graphs that we're going to be analyzing. The zeros are where the graph or the function crosses the x-axis. So we are looking, basically this is a fancy word for the x-intercepts. The local maximum is the highest point in a small area of the graph. The local minimum is going to be the lowest point in a small area on the graph. Now up here I have all these little boxes. These are some cheat boxes on how to use your calculator. It's all about muscle memory, so constantly going through and hitting these buttons is the only way that you're going to really remember where to go. And I have the information here for you in case you forget. So here are going to be directions on how to find the minimum or the maximum. Here is a different ways to find zeros or x-intercepts, finding the y-intercepts, and then changing your window. Now we don't always have to change the window. The window is only if our graph is not within our 10 by 10 view, because we always start our graph at a 10 by 10 window so that we can see what we're looking at, and sometimes we have to adjust it, sometimes we don't. The really important thing about changing your window is that you only want to change one number at a time. If you start changing too many things at once, you don't know what was good and what was bad when you changed it. So we're going to go ahead and go through our first, or our only problem, on how to find our graph. So again, up until now, I have given you the graph that you are looking at, and then you had to answer questions on it. Now it's about you finding that graph yourself. All right, so our first equation, we're going to graph the quadratic x squared minus 8x plus 15. This unit is all going to be on quadratics. So the first thing I did is I hit this y equals button. This is how I'm going to get in to write my equation. X. We are never going to use the x that's the letter in blue. Down here at the bottom you'll see that there's different, not in blue, in green. There's letters in green. We're not going to use those. This is the x that we're always going to use for our variable. Now there are different ways to put exponents in. You can use the caret button, but you've got a shortcut for x squared. This unit is all about quadratics, so everything is going to be squared. X squared minus 8x plus 15. If you did use the caret button, just make sure that you arrowed out of it. Otherwise, you would have been writing 8x and 15 all up in those exponents, and we don't want that. So it's x squared minus 8x plus 15. Also, you want to make sure that you use the minus button, not the negative button. A lot of times those two buttons get mixed up, and then it does give you an error message. Anytime you have an error message, it'll say go to or quit, and the go to, there's no space. You always go to, because it'll bring you to where you made your error. All right, so we have our equation in. We want to graph it. We always start with a normal window, which is a 10 by 10 window. So we go to zoom, and the standard window, that normal window, is number 6. So we go zoom 6. We want to make sure that we can see our entire graph. And in this case, we can't. There's something that we are missing. I have my x-intercepts, so we always check for x-intercepts. We have our min, so you want to make sure that you can see your min or max, and you want to see that y-intercept. I can't see that y-intercept up there, so what I need to do is I need to move my graph up. The way you move your graph to change your window, you go to the window button, and here is window, and it's currently a standard window, 10 by 10 for the x's, 10 by 10 for the y's. I want to move up. Remember, we're going to move one number at a time. X's move it left and right. So if I make my x min smaller, it's going to move to the left. If I move my x max bigger, it's going to move to the right. My y values move my graph up and down. So if I change my y min, it's going to go down. If I change my y max, it's going to go up. I want to move my graph up so I can see that y-axis, or the y-intercept. So I'm going to change it to 20. Sometimes it's just a guess and check. Try something out. If it doesn't work, try again. Not too bad. So we're going to take our graph and we're going to sketch it. When you sketch your graph, it is a sketch, and sketch means it's not going to be perfect. However, everything needs to be in the right quadrant. You're not going to tell me that it's a positive x-intercept, but then draw your x-intercept on the negative side. So just make sure that it's relatively accurate. And actually, this probably isn't that great. I didn't really do much better. It's a little bit higher up than that, but it's not a big deal. The first piece that it is asking me about is local mins and local maxes. Now, because we're going to just be talking about parabolas, you're only going to have one or the other. Whereas in our last unit, we could have had lots of mins and lots of maxes. So the first thing we're going to find in this graph is this min. We don't have a maximum value. To go there, what we're going to do is we're going to make a calculation, and you can see that this is the calculate screen. It's in blue, so I have to hit second trace, and then we're going to choose our option. In this case, our graph has a minimum, so we're going to choose number 3, and then it's going to talk you through the problem. It says left bound. It's saying put your cursor left of the minimum. My minimum is right here, so my cursor is currently left, so I can go ahead and hit enter. I could have scrolled closer if I wanted. Now it's asking me to go right bound. So I scroll on over, I hit right bound. You don't have to go that far. All you have to do is make sure that you've crossed that minimum value. And then it asks you to guess, so you go back towards the middle. Look, I can stay this far away. I don't have to even get that close, but you have to make sure you hit enter a third time. It doesn't actually give you your value until it says min or max, and then it'll bring you to that answer. So it says my minimum value is at 4, -1. Coordinates of the zeros. So the zeros, remember, are just a fancy way of saying x-intercepts. There's a couple different ways to do this. Second trace, there's actually a zero function. I think that's harder. So what we're going to do is we're going to go into y2 and we're going to enter 0 into y2. What this does, as you can see on that color calculator, is it draws a second line. It's creating this red line at the x-axis, and we're going to find those x-intercepts. And actually, we forgot to do this. Anything that we find of our given information needs to be labeled on our graph. So since we found our minimum, we need to make sure that we label that. What we're going to do is we're going to find the intersection point between that parabola and the line. So we're going to go again back to second trace, and we want to find the intersection point. So number 5, or you can scroll down and hit it. It's going to, again, it always prompts you with questions. First curve, it's asking what 2 things do you want to find the intersection of. It's always going to default to y1, which is where our parabola is. We hit enter, and then it pops down to y2. Normally we just have 2 things, but if we have 3 things, then we have to kind of adjust with what we're doing. Second curve, yes, enter. And it asks you to guess. I actually don't even have to move it. I just have to make sure that I hit it a third time. And I can see that it's going to bring me to my first intersection point, which is at 3, 0. And now we need to do that whole thing a second time. So second trace, number 5 for intersection, first curve. Again, at the top left, you can see which equation you're on. You're on y1, the parabola, in blue. Second curve, it bounced down to y2 in red, but you have to scroll this time. If you just hit enter again, it's going to keep on giving you the same x-intercept. You've got to scroll so that you're closer to the other one, and then hit enter. And you want to make sure that the word changes to what you're looking for. Otherwise, you don't have your final answer yet. It says intersection, and that one is going to be at 5, 0. Good. Coordinates of the y-intercept. So the one thing that we know about the x-intercept is that the y value is 0. Something that we know about the y-intercept is that the x value is 0. So our equation is in standard form. We're going to learn more about those forms. And if I plug 0 in, doom, gone, plugged, gone, our y-intercept is at 0, 15. That's one way to find it. Another way to find it is to go back to second trace. Remember, second trace is when we're going to find all of those values, or all those different calculations. This time we want to find the value, number 1, and every y-intercept has an x value of 0, so I'm going to put 0 in for x, and I hit enter, and I find that 0, 15. On this graph, because this is a nice graph and I don't have decimals, I could have also gone to the table of values. The table is right above graph, so I hit second graph, and I could have also found my x-intercepts and my y-intercepts from the table. I can see that x-intercept at 5, 0. I can see my minimum value because it's sandwiched because parabolas are going to be symmetrical. My y-intercept. So you can find a lot of stuff from your table as well. We are actually done with the information on our calculator. Now we just need to do some more analyzing. Increasing intervals. Remember, increasing means that you're going up when you read your graph from left to right. So if I start on the far left part of my graph and I go from left to right, I actually have a negative slope, so that's going to be decreasing. I'm decreasing from the far left, so that's going to be a negative infinity, and I decrease until I get to the minimum value. If you remember, we like interval notation because it reminds us that we're looking at the x's. So I'm going to be decreasing until I get to the 4. And then once I get to the 4, I change directions and I start going back up. So I'm going to be increasing from 4 to the right. We have multiple, sometimes increasing, decreasing intervals, not with quadratics, but what we did in unit 0. And just remember that the left is negative infinity, the right is a positive infinity, and you're talking about your movement from left to right. Your domain are all possible x values. So when we think about our different x values, we took about our movement left and right. So this arrow was forever going up, but don't forget it's also forever going to the left. This arrow is forever going to the right and also forever going to the left. So as I move left and right on my graph, it's never actually going to stop. So this is going to be all real numbers. Your range is the y values. So that's your movement up and down. As I go up and down, I notice that this is going to be the lowest my graph ever reaches. My graph never goes below this point because it's facing up each time. Don't forget that this is the y values. So my graph is going to be everything above a negative 1. And then the last part is going to be your end behavior. So this is saying as x goes to negative infinity, so as x goes to the left, what's happening to f of x, which is a fancy way for the y? My arrow is going up, so it's going to a positive infinity. As x goes to the right, what's happening to my y value is going up, so it's a positive infinity. With quadratics, because you have this U-shaped graph, your end behavior is always going to be the same. They're either both going up or they're both going down. You're never going to have different answers there for your end behavior. All right, so hopefully that's going to help you with our quadratics and how to use your calculator.